Okay, welcome back everyone. Today we're going to talk about 9.3, simplifying radicals. Now, one of the things that we need to understand is when we're doing this process of square rooting things, is that square rooting is just the inverse operation of squaring things. We've talked about how to square things with our exponents. One of the things I would like to start with is I actually want to multiply out or list a bunch of numbers that have been squared. For instance, if we did 1 squared, well, most of us know that's 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. And I'm going to continue on here. I want to list all the way up to 20. I'm going to take a moment and do that. This might be a little boring, but I'll explain why I would want to do that. So 6 squared, 7 squared, 8 squared, 9 squared, 10 squared. Alright, let's do the next 5. 11, 12, 13, 14, 15. Now this is something that, obviously I'm going somewhat fast. You don't have to go as fast as me. You can always just wait till I'm done, hit pause, and write all these down. That would work just fine. Okay, last 5. 16 squared, 17 squared, 18 squared, 19 squared, and 20 squared. So 16 squared is 256, 17 squared is 289, 18 squared is 324, 19 squared is 361, and 20 squared is 400. So, what's the point? Well, the whole point of that is when we're talking about square rooting, we're going to be talking about the inverse operation of squaring. So, for instance, if I am going to be talking about 5 squared is 25, then if I asked you what's the square root of 25, you would tell me, going backwards, it would be 5. If 9 squared is 81, then the square root of 81 is 9. So let's try a couple. I have a couple written down here. And so, again, the reason why I did all this is that if you know what these are, if you don't know up to 20, that's fine, but it'd be nice if you knew up to 15. Maybe 16. So if you know one of these numbers, you know that they are perfect squares, you could then take the square root of them. So, for instance, the square root of 9. The square root of 9 is 3. Why? Because 3 times 3 equals 9. Square root of 121. That's one of our perfect squares. Here it is sitting up here. 121. So the square root of 121 is 11. Now this third one we'd say this 4 root 9. And so what that really means is 4 times the square root of 9. So the way we do that very simply is we just take the square root of 9, which is 3, and then we just multiply 4 times 3, we get 12. Okay. Number 4, negative 100, the square root of that. Well, this one is, hopefully you were thinking this, not possible. Why is that not possible? It's not possible because there's no number times itself that will get us back to negative 100. And this is a big thing right here. If we have a negative number right there inside that square root, that's always impossible. So as soon as you see that, okay, your life's pretty easy. You can just simply write down not possible and move on. Okay, so that's the easy stuff. Those are perfect squares that we're square rooting right there. But what if we don't have perfect squares? What if we have, for instance, like the example I have here, the square root of 8. Some of you might be thinking square root of 8 is 4. Well, no, 4 plus 4 equals 8. But remember, we're looking for numbers that multiply back to get that original number. So I have two basic rules here that we're going to try and solve all 7 of these problems with. The first one is to simplify non-perfect squares, factor, and we're going to look for perfect square factors, and we are going to look for pairs of factors. Now that doesn't seem like that might not make a lot of sense to you right now, but I'll show you how to do it. So let's start here with number 1. So square root of 8. Square root of 8, we can't find the square root of 8 by itself right away. So what we're going to do is we're just going to come up with 2 factors, 2 numbers that multiply together to be 8. 4 and 2, probably the most basic ones. And so this first rule up here says look for perfect square factors. And so one of the rules of square rooting is that you can square root the factors. So for instance, here I've square root of 4 times 2. 4 is a perfect square, and I know what the square root of 4 is. The square root of 4 is 2, so I will simply take the square root of that, and that's 2. That goes on the outside, and we have this 2 left on the inside. Okay, can I do anything with that? Can I factor it more or anything? Nope, so therefore I'm done. So square root of 8 is equal to 2 root 2. Simple as that. Let's do the next one. Now, we're actually going to do this one twice, because I want to show you two things here. So, let's split this in half here. So, square root of 32. Now, the quickest and easiest way to do this is to come up with factors that are perfect squares. So, for instance, square root of 32, two factors are 16 and 2. And I know what the square root of 16 is. It's 4. So I'll bring that on the outside, and I have a 2 left over. I'm done. But let's say I didn't think of 16 and 2. Maybe there's some of you out there thinking 8 and 4. Okay, well, I got 8 and 4, no problem. I still notice that 4 is a perfect square, so I can take the square root of that. So I get 2 root 8. And the problem now is that you're not done. I can simply take a look at root 8 here, and I know I can break that down even more. When I say break it down, I mean find factors. So 2 factors of 8 are 4 and 2. And again, you notice I have a perfect square right here. So square root of 4 is 2. So I'm going to bring this 2 down. There's another 2 from this one, and that one's there. And whenever you bring a number on the outside, you always multiply them together. So 2 times 2 is 4. I get 4 root 2. The exact same answer as what I got the other way. So hopefully that makes sense for you. There's oftentimes two different ways that you can simplify radicals, but they should get you back to the original. Or probably should get you to the exact same answer. Okay, number 3. Square root of 98. Again, we're kind of getting into that point now where hopefully if you're starting to get the idea that it would be a good idea to hit pause and then try it and then see if you come up with the same answer I get. Square root of 98, I think, well, it's an even number, so I know 2 goes into it, and 2 goes into it 49 times. Okay, square root of 49 is 7, so I can bring that out, 7 root 2. Kind of a common little trend. That's just a coincidence here that we've had root 2 every single time. Okay, let's talk about the next one. Square root of 120. Let's see, ends in 0, so I know 10 goes into it, so I can write 10 and 12. Now, neither one of them are perfect squares, so let's break both of them down. So let's see, 10, I can think of 5 and 2. And square root of 12, I can think of 4 and 3. Okay. Now, let's just say, let's do another little for instance here. Let's say you didn't notice that that 4 is a perfect square. What if you broke that down even more? So I'm going to leave the 5 and 2, so they're not perfect squares. Let's say I broke down that 4. And that leads me to my second little rule right here that we're looking for. Is that when you are breaking down factors here, you're looking for perfect square factors or factors that occur in pairs. So for instance, you notice here that we have 3 2's. Well, basically you have a pair of 2's and an extra one. So what is, if I were to multiply those back together, what is 2 times 2? Well, 2 times 2 is obviously 4. So I can take the square root of 4. So square root of 4 is 2. And then I have this 5, this 2, and this 3 left over. And what you do with that, if you can't break them down anymore, is you just multiply them all back together. So 5 times 2 is 10, times 3 is 30. So I get 2 root 30. Okay, let's move on to the next one here. let's see, 3 root 250. So let's go ahead and break that down. 25, let's see, or 250. I know 5 goes into both of them, or goes into that, so I'm going to 5 goes into that 50 times. Alright, neither one of them is perfect squares, so I'm going to break down 50 some more. 5 times 10. And notice here I have a pair. So 5 times 5 is 25, and the square root of 25 is 5. So what you can just simply do as a real shortcut is you just cross out both of them, and you put 1 on the outside to represent them. So I get 15 root 10. Now could I break down 10 more? Sure. 10 is 5 times 2, but neither one of them is a perfect square, so we're done. 15 root 10. Okay, we're going to do just one more. We're going to skip number 7, so we're going to do one more. 4 root 72. So 72 is perfect, or pardon me, it's an even number, so I would probably do 2 times 36. And 36, hopefully, it's one of these from way up here. Square root of 36 is 6. Bring that on the outside. Remember, you multiply. And there you go. So it takes some practice. It's not perfect, or it's not always something that's just super easy. Hopefully, as you get better, simpler ones like the first couple would be easy. But a lot of times it just takes some practice here. It takes some of this breaking things down and seeing if you can find those factors that are helpful to you. So hopefully that makes sense. If you got any questions, make sure you write them down, and we'll talk about them when we get back to class. All right? Thank you.